Hello and welcome to another math video. Today we are taking a look at our Algebra 2 Chapter 4 practice test. This is just for the first four sections. We're going to start by looking at our quadratic function. We've got y equals negative 2 times x minus 2 squared minus 4. Several different pieces of information we want to grab from that. First of all being the vertex. The vertex comes from just pulling straight out of that formula. If we look at that, so the x minus 2, that gives me the x coordinate of the vertex, and then the minus 4, that gives me the y coordinate of the vertex. The general pattern for that is y equals a times x minus h squared plus k, where the vertex is at hk. And so that's what we're looking at for that one. So that's where the vertex is, so I already know where that point is. The axis of symmetry is a vertical line that goes through the vertex, so it has an equation for that is x equals 2. Now it's very important we have the x there. If you just put 2, that's not really an axis of symmetry, it's just a number, it's not a line on the graph or anything. So x equals 2 would be that vertical line that goes through there. Maximum or minimum. In this case, this will be a maximum. So let me circle that. So it's a maximum, not a minimum. Now I can tell that because the a value is negative. That means the graph goes down from the vertex. So the maximum, or the vertex, is really the highest that will get. So I'm going to say that the maximum is negative 4, and that happens at 2. So the maximum is negative 4. It happens when x is 2. The domain is all real numbers. I'm going to go ahead and write that the fancy way, so kind of the double R, like that. So all real numbers, a couple different ways you could say that. You could just write it out too if you wanted to. The range is limited. The highest that the y values, range is the y values. The highest that the y values get is negative 4, and it only goes down from there. So the range, we would describe that as y is less than or equal to negative 4. Now to actually graph this, there's a few different things we could do, but either way we do that, we're going to start with the vertex at 2, negative 4. So if I plot a point there at 2, negative 4, it would be right here. So we've got our point there at 2, negative 4. From there we need to find points on both sides of the vertex. Now, so you could just plug in a 1 to your equation for x, plug a 0 into your equation for x, and you could just find out what those y values would be. But there is a pattern. The way I look at the pattern is if I move away from the vertex, I square however far away I move, talking horizontally, and then multiply that by whatever a is. That tells me how far up, or in this case down, you will move from that vertex. I would start with moving out 1. So you square 1, you get 1, but then you multiply that by negative 2, since that's the a value, and you get negative 2. So if I go out 1, I go down 2. And I'm specifically saying out because it means out either left or right. It's the same thing. It's a parabola. It's symmetric. Remember, we talked about that axis of symmetry. That is at x equals 2, so right there. I'm just going to get rid of that because I don't like the way that looks. But certainly that's where that axis of symmetry would be. Now if I go out 2, I would square that and get 4, and then I would get down 8 really. So I'm not even going to get out that far and still be on my graph. So it's kind of too bad I don't have another point. If I wanted to, I could find another point. If I went out a half, I could square a half and get 1/4, multiply that by negative 2, and I get negative 1/2. So if I go out a half, I go down a half. Not too tough to plot that point. It does give me one other kind of pair of points there. And I'll go ahead and draw my curve through those. I'm going to be careful not to get over to 0 because I'm not supposed to get down that far yet. So that's what my graph would look like, and again that should confirm that range as well, that all the y values are less than or equal to negative 4. We'll go through the same basic process for number 2. Vertex in this case would be negative 1, 0. Now it's a little bit weird because there is no k value. Don't let that mess you up. So negative 1, 0 is the vertex. Axis of symmetry then, just x equals negative 1. Again, it's x equals whatever the x coordinate of the vertex is. Now this parabola is going to go up. So in terms of a maximum or minimum, we're looking at a minimum. Minimum would be 0, and that would happen at negative 1. So minimum is 0, it happens at negative 1. Domain is still all real numbers. The range is going to be limited. Again, if negative 1 is the minimum, then the values of y are all greater than or equal to negative 1. And so that's what we're looking at for that information. Then we go through our process to graph it, starting with a point at negative 1, 0. Alright, and then notice on the last one too, I did get to 5 specific points. I did have to, again, go out a half in order to get one that would fit on my grid, but it did work out. In this case, kind of do the same sort of thing. Now if I won't go out 1, we square 1, which of course gives us 1, multiply by 1/4. So if I go out 1, I'm only up a fourth, so that's not very far at all. I don't even think I really want to use that point. If I go out 2, we square 2 and get 4. 1/4 of 4 is 1. So if I go out 2, it's up 1. And so that works out well. Out 2, up 1. I don't mind using that point. Out 3 wouldn't work very well because I'd have 9/4. Out 4 would work well though. 4 squared would be 16. 1/4 of 16 is 4. So if I go out 4, I actually go up 4. And I end up here. So that's probably the best choice for points that makes sense. Let's see, if I went out 6, just to be curious here, that'd be 36, square that, or multiply by 1/4, we get 9. So actually I am still on the grid there. So maybe I'll just do that anyway. For some reason it doesn't want to write right there. There we go, I got that one. See if I can get this one. For some reason it doesn't want to write right there. So I'll just draw the curve in with what I've got. And there we go. So that's what that one would look like. And again, I did do an extra point there. Would have been 2, but for some reason it doesn't want to write there. So, but certainly that's a good curve for that one. Alright, and then last one for this page, writing the equation of the graph in vertex form. So I need to first of all identify where the vertex is. In this case it is at negative 2, negative 1. So that gives me my h and my k. So h being negative 2, k being negative 1. And again I've got my form a times x minus h squared plus k. Now I'll kind of go through a couple different ways to look at this one. So I know the vertex. That gives me h and k. If I can figure out a, that's great. In this case, I should actually be able to do that because I've got my vertex here. And if I go out 1, I can see that it's up 2. So if you can see what your out 1 movement is, really that's your a value. A is 2. Now if that does not happen to be a nice point, then the process would go something like this. You'd need to find a nice point. In this case, I'll use the negative 1, 1. So we find some other point. We plug that in for x and y. So y is 1. Again, we're pretending we don't know what a is. X is negative 1. Minus a negative 2, so that's really plus 2 squared. And then minus the 1k value, so minus 1 there. This will give you an equation that you can solve for y. Let's see, so we get just a 1 squared here, minus the 1. So 1 squared is 1, so 1 equals a minus 1. Add the 1 to both sides. And we found out that a is 2, like we had, again, figured out earlier just from the out 1, up 2 process. Now to actually write that then, let's see, we would have y equals 2, and then x plus 2 squared minus 1. That's our equation for that parabola in vertex form. And brings us to number 4. They're giving us the equation in standard form, and they ask for the vertex, maximum or minimum, domain, and range for this equation. So what we need to do is use the equation for the axis of symmetry, which they don't ask for. Bring this down a little bit. So opposite of b over 2 times a. Let's see, a is positive 2, b is positive 3. We don't really need c for this. It's negative 10 if you're curious. So the axis of symmetry would be negative 3 over 2 times 2. So that would be negative 3/4. So we get negative 3/4 for the axis of symmetry. That also tells us the x-coordinate of the vertex. So we know that that is negative 3/4. And we can use that in order to find the y-coordinate of the vertex. Now, I used a calculator because I didn't want to bother plugging that in. You certainly could do it by hand, but it does get to be a bit of a pain. It does turn out to be negative 89/8. If you've worked with me, you know my distaste for rounding things if it's not necessary. So negative 89/8 being the exact fraction that we have. That decimal you don't actually need to round, really. This one would be a minimum again. Again, the a value tells me that parabola goes up since it's a positive a value. So I know that the minimum is the negative 89/8. Now, just so you know, in case you're curious, that's negative 11.125, and that's exact. I haven't rounded anything. That happens, of course, at negative 3/4. The domain, as with all of these quadratic functions, is all real numbers. And the range is limited. The minimum would be the negative 89/8 or negative 11.125. So the values of y are all greater than or equal to, I'm just going to use the decimal, negative 11.125. So there we go. That answers all of those questions. That brings us to number 5. Again, we've got another equation in the standard form. Again, I'll use the opposite of b over 2 times a in order to find the x-coordinate of the vertex. So x equals negative 2 over 2 times negative 1. So we get a 1 for the x-coordinate of the vertex. And then if we plug that in to the equation, y would equal negative, and then 1 squared, that's parenthesis, plus 2 times 1 plus 3. So we get negative 1 plus 2 plus 3, which of course would be 5 minus 1, so the y-coordinate of the vertex is 4. So I know the vertex is at 1, 4. I guess we'll go ahead and graph that. And again, you could just plug in values around the vertex. And actually, since it is in standard form, I know that c value is the y-intercept. So when x is 0, y is 3, which confirms, again, our pattern of out 1, in this case down 1, because you square 1, you get 1, multiply by the a value, though, which is negative 1, and of course we get to negative 1. And the domain, of course, is all real numbers. The y values are going to be less than or equal to, again, that vertex is a maximum. So the y values are less than or equal to 4. And then they want the vertex form as well. Let me finish graphing maybe first. So if I go out 2, then I would go down 4. Again, squaring 2, I get 4. And then it's just a matter of multiplying by a negative 1 to get that negative. They said 5 points. I'm going to go more because I don't like to be inaccurate. So if I go out 3, that's down 9. So I get a couple more points there. And if I draw a curve through those points, should look something like that. There we go. And I have all the information I need for my vertex form. I know the vertex. I know a is negative 1. So vertex form, y would equal negative 1 times x minus 1 squared. Don't forget the squaring. I've seen people do that plenty of times. And then plus 4, because that's the k value. That answers all of those questions. Alright, for number 6, again, this would really be a project for the graphing calculator, so I can talk you through it, but won't be able to show you very much. So really what we would do is, for the weeks, we would enter that in as list 1, and the population would be list 2 on the calculator. So you hit the stat button, you choose to edit. If you have things in your list, you'll need to clear those out. And then proceed by entering the weeks in for list 1 and the population for list 2. Once you have that finished, then you can go to Stat and Calculate in order to do this next part, finding the quadratic function that models the data as a function of x, the number of weeks. And you run that quadratic regression. And if I remember right, this one actually turns out to be nice values. You should be getting a 5 for A, negative 17 for B, and 495, just being kind of messy there, 495 for C. So no rounding there. And again, so that's our model, and they want us to use the model for part B to estimate the number of fish in the lake on week 11. And so there's a couple of ways you can plug an 11 in there with a nice model like this one. It's not too bad. It ends up being 913 fish for that week 11. And then part C, during which week is the population the lowest. So let me kind of talk you through that one. What I did is I found the vertex. So I used the minimum function on the calculator. So I had to use the graph. So if I didn't already have the equation, the model, typed in as y sub 1, I would need to do that. So you want to have that entered in as y sub 1. And then you need to make sure that you adjust your window to fit what you need to look at. So again, if you look at the different values in the table, that can give you an idea of what you need to have for your window. Now, when I did this, I did try it a couple times and I changed my window settings. I did notice that depending on the window settings, I was getting slightly different values. So that is an issue. It's funny looking 8. That is an issue. Still funny looking 8. But one that we can kind of work with. Here's the values that I got. And I couldn't tell you the window settings, I don't remember. But I do know I got a couple different things depending on the window. It didn't change the answer to the question. But the answer to the question gets to be a little bit interesting because the vertex happens at 1.7, gives us a 480.55. And again, we are basing this on the model, not the plain numbers. But still, what we're looking at there. So then I was trying to figure out, okay, how do I answer during which week is the population the lowest? Well, really, if you think of it, the time from 0 to 1, that's really week 1. So that's week 1 that we have, and then the time from 1 to 2 is really week 2. And for some reason my lightsaber's not working. There we go. Time from 1 to 2, that's really week 2. So if the lowest time happens at 1.7, then that means that the lowest population is really during week 2 to answer that question. Okay, and then on the last page we've got 6 different factoring questions. We want to factor them completely, of course. And these are going to be just 1 point. It's either you factored it correctly or you did not. So make sure you're being very careful with this. Make sure you take out any common factors and you actually have everything in the right place. For number 7, with a negative x squared, the number one very first thing we want to do is factor that negative out. It's something of a common factor, but a little bit different concept there. So we get a positive x squared minus 2x minus 80. So we're just going to leave that negative out there. If I focus on the factors for the x squared, I get 1 and 1. And for 80, I do get several factors. Boy, I don't really want to list these all out, but I guess I will. So 1 and 80, 2 and 40, 3 doesn't work, 4 and 20, let's see, 5, and that would be 16, 6 does not work. 7, of course, doesn't work. 8 and 10, and that would be it. So now with a negative 80, that means that one of the numbers has to be negative, and I would assume the larger of the two, since the negative 2x is negative. And I'm looking for the pair that have a difference of 2, really, so that brings me straight to the 8 and negative 10. So my answer then ends up being a negative out in front. We've got an x in each one. Since they're the same, it does not really matter which one goes where, but we get plus 8 and minus 10. And so that's the factored form for number 7. If we look at doing the same sort of thing for number 8, very first thing we can do with 8, though, is we can actually factor a 2 out of that. If we do that, we get 7x squared minus 4x minus 3. It's a little bit smaller numbers to deal with, and if I look at the factors for 7 and for 3, it's a pretty short list. Let's see, we might guess that the 3 would be negative, and if we're wrong, we can just switch that. Really not many ways to put that together, and of course 7 multiplying the 3 would be way too small. It would be a negative 21. So it's got to be the 7 and the 1. That would give us 7, and then minus 3. Whoop, so there we go. That should be a positive 3 and a negative 1. So we get negative 7 there, positive 3 there for negative 4x. So we still have the 2 out front. We have an x and a 7x. Again, they are different, so we need to make sure we put everything else in the right spot. So the 7 is multiplying the negative 1. That means the negative 1 has to be in the different binomial than the 7, and then the plus 3 would go there. Because I didn't write my answer in a line, but there you go. That's the answer for that one. That brings us to number 9. There actually is not a common factor at all here. So we could begin by looking at the factors for 18. It's a little bit of a list. 1 and 18, 2 and 9, 3 and 6, completing that list. And the factors for a negative 14, again, I'll just write that out as positive 1 and 14, 2 and 7. Again, we might guess that the smaller number would be negative, since the 9x is positive. Now there are quite a few different combinations here, but remember, we're looking for only a difference of 9, so some estimation can go a long way here. And typically in that kind of situation, if it's going to be a 1 and a 14, that would be kind of a unique thing. In this case, it does not turn out to be the 1 and the 14. It turns out to be the 2 and the 7. And really the way we end up getting this to work is we have a negative 12 here and a positive 21 there. That's how we get to our positive 9x. So we know we would have a 3x and a 6x. And let's see, the 6 multiplies the negative 2, so minus 2 goes there, plus 7 goes there. I missed putting it on the line again, but there you go. That's the answer for number 9. Alright, number 10 might strike you as odd, just being that there's only 2 terms. One thing we can do, though, is we can take out a common factor of a 2. So if we do that, we take that 2 out, that leaves us with 9 squared minus 1. Now hopefully you didn't jump the gun and think we were done yet, because we kind of landed in a difference of 2 squares. So that 9x squared minus 1 does factor as 3x plus 1 times 3x minus 1. So it does work out as we see there for that one. Brings us to number 11, where we can factor a 2x out. So I take that 2x out, that leaves me with 4x plus 3. And that's actually all we can do there, is factor that 2x out. It gives us 4x plus 3, so that's our answer right there. Didn't mean to draw through the 2. Try that again. There we go. And that brings us to our final question, number 12. There is no common factor that we can take out. So we'd be looking at the factors of 6, which would be 1 and 6 and 2 and 3, and the factors of 15, which are not very much, 1 and 15, 3 and 5. Now, since the 15 is positive, then our two values, the 1 and 15 or 3 and 5, have to have the same sign. Since the 19 is negative, then they would both be negative. So no guesswork there. Then we're just looking at how do we combine those to get the negative 19. Again, there's only well, there's a very small number, really, of options available to us, especially if you know how to use the common factors to eliminate some choices. But what we end up with is the 3 times the negative 3 and 2 times the negative 5. So that leaves us with negative 9 and negative 10 for our negative 19. So we end up with 2x here and 3x there. The 3x multiplies the negative 3, which means the minus 3 has to go there. And it would put the minus 5 right there. And there we go. Well, thank you for watching, and hopefully this is helpful.